Afternoon, everyone. Hope you've been enjoying the day. My name is Mark Deguara. I'm the General Manager for Data Centres. So, the topic, how AI is driving the infrastructure in the data centre, from the core to the edge. So if we look over the last couple of years, it's quite interesting. If you look at the World Wide Web, it took 7 years for 100 million users. I mean, you would have seen this earlier this morning in the plenary session. It's only taken 2 months to get 100 million users for ChatGPT. Interesting enough, at the same time, if you look at energy consumption, where it's being extrapolated out to, if you look out to 2050, you can see the amount of energy that's going to be consumed is going to be huge. Data centres are certainly playing a significant part in this growth in energy, whilst we're seeing, obviously, the decarbonisation and electrification. What's really interesting is the point number 2 there. 3 billion more people needing access to electricity by 2050. So think of that, 3 billion more people by 2050 are going to need electricity. And our wonderful space that we work in, data centres, is helping drive the efficiencies around electricity as well. So, a new digital economy is impossible without it. So if you have a look at some of the numbers up here, I'll let you read that for a few seconds. Just have a look at those numbers. The one for me that's really interesting in the data centre space is the top left. 90% of the world's population by 2030 will be using the internet. So think about that, 90% of the world's population by 2030 will be using the internet. And what's sitting behind that? Data centres. Infrastructure to support the internet. AI is the next industrial revolution for lots of reasons. AI certainly, at its most basic form, is driving things like ChatGPT. But ultimately, what is it driving? It's driving things like machine-to-machine learning, machine-to-human learning. It's actually optimising the way we're doing things. It's bringing out new use cases in everything we do. The other thing it's doing is absolutely driving the economy. $60 billion worth of investment year to date in terms of investment in AI. Now, that's not just AI in data centres. That's AI, all the use cases where the technology is actually being used. So if we take AI and then move it out to what's actually happening, there's 2 different models. There's the development model, that very much around the machine learning or large language models. So that's development, that's training, that's building the models. So once we've built those models, what happens with it then? It moves to a use case. You know, ChatGPT's a use case as an example. Machine-to-machine learning is a use case. Where is that technology being used? Yes, it's being generated in the data centre. We're actually building the use case. But then we're moving it out into the real world. The really interesting thing sitting here today is most of the use cases we're going to see don't exist yet. People are developing, businesses are developing new use cases all the time. And that is going to drive more and more of what's happening in terms of this space. So the deployment brings its own challenges. So when we start to deploy this technology out into the marketplace, capacity constraints on data centres, the vacancy rates, also the rental rates. When I say rental rates here, it's not real estate. Of course, if you're buying property in Sydney, you might look at it and say it's the same thing. But the costs of rates are going up. The design impacts. I've never seen so much change in data centres in the last 2 years than I've seen in my previous 25 years in the space. The impact that AI is having on the development of both data centres at the core and infrastructure at the edge in the last 2 years has been greater than the previous 25 years. Why is that? Why is that? The reason behind it is it's the unknown. Our friendly friends at NVIDIA, for example, they bring out a chip. The next year they bring out a chip that consumes twice as much power. The following year they bring out a chip that uses 3 times more power. And the industry itself is doing that. And that is having huge impacts on what it's having from an infrastructure perspective in the data centre space. So let's have a look at that. AI is accelerating. Have a look at these numbers. 150 gigawatts of extra capacity in the next 5 years. So 150 gigawatts of extra capacity. Give you an idea, the eastern seaboard of Australia is around 30 gigawatts of power. So 150, so 3 times more than the eastern seaboard of Australia generated globally is going to be consumed in data centres. Racks, 40 to 100 kilowatts. I don't know if anyone read an article from about a week ago. They're talking about an 840 kilowatt rack. It's an 840 kilowatt rack. We were talking downstairs in the Innovation Hub, a 1 megawatt rack. Where's it going to stop? Is it a 1 megawatt rack? Is it a 2 megawatt rack? Who knows? But regardless of what it is, it's putting large challenges around how you design and build data centres and the workloads to support them. So, to drive the new era of data centres, what are the things we need to do? Top left, optimise power capacity and efficiency. Optimising power for lots of reasons. One, optimising what's available, so using what's available, access to the grid, and ultimately efficiency. The more efficient we can make a data centre, the better. Deployment of high-density infrastructure, that challenge. How do we work around high-density infrastructure? And last but certainly not least, enhance sustainability practices. With all this going on, the underlying thing is sustainability. There's a bit of a conflict, some people say. We're using all this power, but we've also got to be sustainable at the same time. If you do it well, you can actually achieve both. But it's working together as an industry to achieve that. So, welcome to the new era of data centres. So what is this new era of data centres? Yes, we're still going to have the traditional data centre in air-cooled. We're still going to have what we call cloud computing. AI is around high-performance compute. High-performance compute and overlaying infrastructure on top of that to support it. Rapid compute evolutions. I mentioned before, NVIDIA. You know, the power increases double in 1 year, increases 3 times the following year. Ultra power density, you know, getting power into a space. Interesting enough, if you look at the new UPS we've got downstairs, and I'll talk about that shortly, we're starting to hit the limitations of how much copper you can actually get into that space. When I say copper, that's the electrical connection. That's getting the power into it and getting the power out of it, let alone the density of the rack itself. Race to AI leadership. You could argue there's an arms race in AI leadership. Is that NVIDIA? Is that Microsoft? Is that AWS? Doesn't matter who it is, there's this race. You know, governments are actually, inverted commas, fighting over where that AI gets deployed. Dynamic profiles. It's interesting, once again, if I use NVIDIA as a discussion, the profile of that chipset, it peaks at 1.8 times its power consumption. So if it was running at 1, it actually peaks at 1.8 times. How do you deal with that when you're designing something? And last but not least, architecture variability. What I put in today, is it still going to be valid in 12 months' time? Interesting enough, in the last 12 months, I've actually seen a number of data centre providers do a design, and fundamentally, before they've deployed it, they've actually changed it and or stopped it and said, hang on a minute, if I'm going to employ or deploy millions and millions of dollars worth of capital or billions of dollars worth of capital, is what I'm deploying today actually going to be useful in 12 months' time, let alone 5 years' time or 10 years' time? So, energy strategy for the AI area. So if we're looking at energy strategy, what are the things we've got to look at? Energy procurement, on-site power generation, battery and backup resources, and managed power sources. So this is actually talking about where the energy is coming from. If we look on the left, prime power. So is prime power from the grid, or is it actually generation on site? Backup power. Is backup power diesel generators? Now I've heard some people saying, well, we're going to stop the availability of diesel generators in 2030. So no more diesel generators, so what is my backup power? Is it gas turbines? Is it energy storage? Is it nuclear reactors? What is it? So it's an interesting challenge that's facing us all, because the data centre, when we're talking some of the scale and sizes we're doing, what impact are we going to see? And last but not least, available power. Where's that power coming from? Is it renewable? Is it wind? Is it solar? Is it energy storage? Where is that power coming from? And if I look here in Australia and New Zealand, when I say where is it coming from, is there enough power available in the grid? Can the grid support the growth that we're seeing? Can anyone answer that question in this room? Probably not. Can our governments answer it? Almost definitely not. So yeah, I won't get into politics, but yeah, that's another challenge for us, is governments and where they're going to support data centres. And they also need to realise that the data industry is actually driving huge economic growth. So it's important for all of us that we work with our governments to achieve an outcome. So challenges. If we look here and look at the challenges, strategic energy sourcing, on-site power generation, managed power sources. These are the elements that we need to look at. You know, if we look at global data centre operators, you know, $9.5 million is what we've saved in leveraging flexible power. So as part of Schneider's business, we have the ability within our sustainability business to actually support organisations in where they procure their power from, how they gain access to that power as well. So Schneider Electric is also here to be able to support organisations in where they actually get that power from. So end-to-end AI. Sustainable, AI-ready data centre designs, AI-ready high-performance powertrains, hybrid and high-efficiency cooling solutions, and safeguard your operations. At the end of the day, when you're looking at AI, it is an end-to-end solution. It needs to be sustainable, it needs to have high-performance powertrains, and ultimately, the last point is critical, safeguard your operations. But where does it all start? It all starts at the chip. In this case, I'll talk about NVIDIA. They're not the only ones that make GPUs, of course, but we'll talk about NVIDIA here. So when you're actually looking at an AI solution, as a manufacturer like Schneider is, how do we develop products? How do we develop solutions for an AI era? We have to work with the chip manufacturers. We need to understand where that technology is going. There's no point us building something in isolation that is not going to support what is coming in the next 6, 12, 18, 36 months, etc. So one of the things we're doing with NVIDIA is we've come out with reference designs. We're working very closely with them around, okay, if I'm going to develop a particular compute, what is the infrastructure as a manufacturer we need to build to support that deployment? Because it's great to have this new wonderful chip that has a certain capacity, but if you can't support it, then it is useless. Now, NVIDIA or the chip manufacturers, as an example, they're not infrastructure builders. Schneider Electric is. And the way we can support the industry is actually working alongside these organisations. So where are we? One of the things we do, and if you look at our innovation hub, we talk about grid to chip and chip to chiller. So it's an AI-ready high-performance powertrains. So we look at the low voltage, medium voltage switchgear. We look at UPSs, high-efficiency UPSs. Now, I spoke about before the NVIDIA chip spiking at 1.8 times. Once again, it's developing UPSs that can support that fluctuation in power. High power final distribution. So to give you an example, we're talking about 1,000 amp rack distribution, PDUs. We're talking about 1,000 amp busways. We're talking about a lot of power and its density getting to the rack. And last but not least, racks and containment. How much weight is going to be in those racks? Especially if you add liquid cooling to it. So you're talking potentially 1.5 to 2 tonnes in a rack. Now that throws up other challenges. Yes, the rack itself, but of course weight loading of the building. So these all intertwine together to give us a solution. And one of the things we need to consider is everything from the grid to the chip and how we get power from the grid to the chip. And funnily enough, how do we get chip to the chiller? So you've got the chip, we're generating heat, how do we reject that heat? So just a quick little product pitch here. We have released our new UPS, the GVXL. It is on display downstairs in the hub, but it's a high efficiency UPS in a very small form factor. It's 1.2 metres wide and it is 1250 kilowatts. It's actually 1.2 square metres with a power density of almost a megawatt in that footprint. From a sustainability perspective, to give you an idea, it's roughly a third of the footprint of our existing UPS for that same capacity. And from an industry perspective, it's around 25 to 30% less than anything in the industry when it was released. So chip to chiller. So, as I said, we've got the power to our chip. That chip's generating heat. How do we get that heat out? So there's a couple of ways to do it. liquid cooling, air cooling, is two key ways to do it. Traditionally, we have used air-cooled. However, once we get above 50 kilowatts a rack, and there's lots of arguments whether that's 20, 30, 40 or 50, but at 100 kilowatts a rack or 800 kilowatts a rack that I spoke about before, without question, it has to be liquid. You have to be able to remove that heat. So, liquid cooling distribution units. Liquid to air. So liquid to air, for example, if you've got an existing data center, for example, and you don't have the ability to get that liquid in, what you can do is go an air-cooled unit and air to liquid. We also have high temperature chillers. Interesting enough, and Maurizio in the presentation later this afternoon will talk about high temperature chillers. The higher we can get the chilled water, the more free cooling we can get. So if we can run a chiller with much higher temperatures, it means we don't have to run compressors. So our efficiency goes up dramatically. And then we also have air-cooled and generic chillers as well. So, a little bit of interesting information. Schneider Electric's got a 50-year plus history in cooling. From the days of Airflow, APC and Uniflare. We acquired Motivair, and that acquisition went through at the end of February. So Motivair by Schneider Electric, that has brought a whole new range of liquid cooling to our offering. You will see that product on the hub downstairs. So once again, if you're interested in having a look at our liquid cooling, you'll be able to see that as well. Once again, there'll be a more in-depth dive this afternoon on liquid cooling and the Motivair product as well. So I've spoken a lot about data centers and what's changing in the data centers, the high capacity requirements, etc. But what's happening at the edge? We conducted a survey and we've done some industry research, and Schneider Electric's found that if we look at where we are today, or 2023, about 4.3 gigawatts of AI consumption, that's going to move somewhere between 13.5 and 18 gigawatts. But what's really interesting, if you look at the bottom right-hand corner, roughly 50% of the AI requirements is going to be at the edge. What does that mean? Now, is that AI compute at the edge? Yes, certainly some of it will be, but it's also AI applications at the edge. So we've actually done some surveys here in Australia. So TRA have done some research and what's happening in the Pacific. Interesting point. 16% in Australia and 9% in New Zealand intend to build their own AI solutions. Certainly that's larger enterprises. AI spend, where is that going? Security and datas. And then who's controlling it? Interesting enough, on the left, the boss, inverted commas, the CEO or the MD, having a leading role in AI projects. What I find really interesting is the one on the far right. Partners are the key. To be able to develop AI solutions within your business, partnering is in key. Even if I look at Schneider Electric, if we look at AI and the way we're developing AI, partnering is key to us as well. But the industry as a whole is very much depending on partnering. And this is an Australian-New Zealand view. This is not a global view. This is an Australian-New Zealand view. And where is it driving us? Manufacturing, education, energy utilities, retail, life science, financial services. It doesn't matter where you play in the industry, AI is having an impact. Not necessarily at front of mind, like when you're talking to these businesses, you're going, oh, where's AI playing? AI might be playing in the background in driving energies. It's playing new applications. It's providing new use cases. Once again, if we look at Australia and New Zealand, 84% of the research participants said they are investing AI projects. Most generative AI, things like ChatGPT, and actually using that in your business. So simple things like, and I know within Schneider, we have our own version of ChatGPT, which we call Copilot. It's actually based on that platform. Simple little things like, I can't find a file on Teams in the email, someone's SMS me, text me, I can do a little search, and boom. So something that was probably taking me 5, 10, 15 minutes to find something, if I could even find it, it's finding a lot quicker. And that's a simple example within our business. And the other one is 73% agree with the statement that they will use the same partner they use today. That's interesting. So they're saying 73% of organisations will use the same partner that they are using today to support them around AI. I don't know whether I necessarily agree with that one, but it's an interesting statement. So let's have a look at use cases. So we looked at the mining industry, we looked at retail, and we looked at electricity. This is where the investment is going. I'll just pause there and have a little bit of a look around where that investment is going. I'm going to pick one, retail. I'll use you in a little example. So who knows Lowe's, as in the clothing company? Who doesn't know Lowe's, the clothing company, is probably a better question. So, Lowe's. So why am I talking about Lowe's? So sales and marketing as an example, but this is more around procurement. So what they've done is they've actually deployed cameras, and they're doing tests around this, actually deploying cameras in their stores with AI. Now, you think, oh yeah, they're going to be tracking people in and out. No, it's not for tracking us. What it's used for is actually looking at the racks. What they're looking at the racks of clothing and going, okay, the AI is actually looking at when do I need to replace the clothes, i.e. that rack's empty and I'll fill it back up. So there's an AI application that's saving time. So instead of having someone walking around the store working out, well actually I need to fill that rack up or that one, they're using AI to do that. Why I bring that example up is because people think of AI at the edge of taking my 100 kilowatt liquid cool rack and sticking it at the edge. Maybe yes, you might do that in some applications, but really what AI at the edge is those use cases. If I take that example of Lowe's, what's supporting that application at the edge? Is it UPSs supporting the cameras? Is it a storage device on the site? Is it a network? That is generating businesses in itself. So AI is actually driving use cases. And there's many more like that around AI at the edge. So it's not about necessarily taking compute and sticking it at the edge. It's about the edge and the use cases. And from a partner perspective, that is driving our industry to develop more and more and more. Not just about IT, but about the use cases around AI. Partnerships. I spoke about Schneider and needing partners. If you look at this slide, it's talking about what Schneider Electric does with its partners. We have the chip manufacturers, we have the server manufacturers, we have the integrators, whether that's tech integrators or system integrators, and ultimately we have the hyperscalers. For us to be successful at Schneider, we need to work with our partners. Otherwise, we can never generate the solutions and products we do today to help you and the industry. So if I take this to the next level, if I look at our partners and say, here's a bit of an ecosystem of all the different players that we can play with. Now you as partners can do this. If you look at the top, you have the enterprise businesses, whether that's healthcare, financial services. You have the consulting services. You have the application layer. You have the server manufacturers. And then you have the alliances. And ultimately, networks and storage. Once again, it's very much around partnership and working with these partners to develop your AI solutions, or more importantly, help customers with their AI solutions and supporting those. And something that if we looked at 3 years ago, every data center presentation was on sustainability. Every presentation now seems to be on AI, but it is underpinned by sustainability. It's absolutely critical. Align sustainable strategies with business growth, drive power and water efficiencies, decarbonising operations, decarbonise supply chains, prioritise low embodied carbon products and materials, and ultimately compliant sustainability reporting for stakeholders. Sustainability, it's at the core of everything we need to do. Interesting enough, if we rely on governments around sustainability, we'd probably be still waiting in another 20 or 30 years to do it. But sustainability needs to be the core of everything we do. And from a Schneider perspective, it certainly is at our core and very much working with our customers around that. So, if you want to check out the little QR code, there's lots of little bits of information. But in terms of sustainability, my next presenter, which is Astrid Groves, is going to talk a little bit about sustainability. And that's a little bit of a snapshot on the data center. That's grid to chip, chip to tiller, and going AI from the core, which is our data center environment, to the edge. And as I said, the edge is not just about compute at the edge. So I've got 30 seconds. And if anyone wants to ask the question, apparently Astrid's going to give me 5 more minutes. Is that correct, Astrid? So who would like to ask a question? Somebody. Sure, there's somebody in the room who'd like to ask the question. Speak now, or ever hold your peace. No? Come on, there's got to be one. Bonus points for someone that can ask a question. Okay, going. It's not an auction. Okay, all good. So thank you all. Enjoy the next lot of presentations, and I will hand over to Astrid Groves.